Dear learners, in this e-content, we will discuss the calculation of W, Q, delta E and delta H for an isothermal reversible expansion of an ideal gas. Before solving the problem, let me quickly recall the basic concepts involved. First, the system we are dealing with is an ideal gas. A gas is called ideal when it obeys the fundamental gas laws, Boyle's law, Charles' law, and Avogadro's law. It also follows the ideal gas equation PV is equal to nRT. It also satisfies the postulates of the kinetic theory of gases. Second, the term expansion means that the volume of the gas increases during the process. Third one, the condition is isothermal, which means that temperature remains constant throughout the process. Even though heat is exchanged, the temperature does not change. Finally, the process is reversible. This means it is carried out very slowly under controlled conditions and requires a driving force. It is non-spontaneous. Now, based on these facts, let us calculate the parameters one by one. First one, calculation of delta E. By definition, for an ideal gas, internal energy is a function of temperature only. We know that for an isothermal process, temperature remains constant. That is, initial temperature T1 is equal to T2. Change in temperature delta T is equal to 0. Therefore, delta E is equal to 0 at an isothermal condition. This is equation number 3. Second one, calculation of delta H. We know that by definition of enthalpy, H is equal to E plus PV, where H is equal to enthalpy, E is equal to internal energy, P is equal to pressure, V is equal to volume. We know that H is a state function, therefore the above equation number 4 may also written like this. Delta H is equal to delta E plus delta PV. This is equation number 5. We know that for an isothermal condition, delta T is equal to 0, therefore delta E is also equal to 0. Now substitute this value in equation number 5. Finally, we get delta H is equal to delta PV. This is equation number 6. We know that for an ideal gas, PV is equal to nRT. This is equation number 7. The above equation may written like this. Delta PV is equal to delta nRT. This is equation number 8. Here, at an isothermal condition, delta T is equal to 0. Therefore, delta nRT, the whole term, is equal to 0. Substitute this term in equation number 8. We get delta PV is also equal to 0. This is equation number 9. Substitute equation number 9 in equation number 6. Finally, we get delta H at constant temperature is also equal to 0. This is equation number 10. Third and fourth one, calculation of W and Q. We know that according to first law of thermodynamics, delta E is equal to Q minus W. This is equation number 11. Here, we know that at an isothermal condition, delta E is equal to 0. Therefore, Q minus W is equal to 0 or W is equal to Q. This is equation number 12. We know that W is equal to P delta V. This is equation number 13. In a reversible process, ideal gas expansion is done in infinite step. Let us consider for a single step the above equation number 13 may also be written like this: dW is equal to P external dV. The major difference in between equation number 13 and 14 or equation number 14 provides an information about the small change. Okay, reversible expansion takes place when external pressure is slightly less than to actual gas pressure. External pressure is represented by P ext. Actual gas pressure is represented by capital P. Therefore, the external pressure is equal to actual gas pressure is subtracted by the difference dP. This is equation number 15. Substitute this value in equation number 13. We get dW is equal to PdV minus dP dV. This is equation number 17. Here dP is change in pressure, dV is change in volume. The condition is reversible, therefore dP dV is small, that is the negligible change. Hence, both the terms are neglected. Finally, the above equation is written like this: dW is equal to PdV. This is equation number 18. For a given state change, integrate the above equation, we get equation number 19. We know that for 1 mole of an ideal gas, PV is equal to RT. Rearrange the above equation like this: P is equal to RT divided by V. This is equation number 20. Substitute the meaning of P in the above equation. Equation number 21 is originated. That is W is equal to integration of RT dV divided by V. Integrate the above equation. Finally, we get the meaning of W. W is equal to 2.303 R into T log V2 divided by V1. Integration of dV divided by V is equal to ln V2 divided by V1. Okay. For an isothermal condition, W is equal to Q. Therefore, the meaning of Q is also equal to W. Therefore, Q is equal to 2.303 R into T log V2 divided by V1. That is, an ideal gas expands isothermally and reversibly. The meaning of delta is equal to 0. Delta H is also equal to 0. W is equal to Q, that is 2.303 R into T log V2 divided by V1. Thank you very much for watching.